OK，各位同学，大家早上好。OK，今天我们要上这个应用力学2的第一课。So, good morning. So today is the first lecture for Applied Mechanics 2. So I'm your instructor, Kim Jong Lau. So let me have a brief introduction about the course. Okay, before giving an introduction about the course, let me have my self-introduction first. Okay, about myself, I joined NYCU since 2019. So my research area including actuator, vacuum drone, soft robotics. So what you can see here is in the next slide. So in our lab, I used to make actuator on wafer. So what you have since here is a cone that is filled up with the epoxy glue, and when you heat up, then you can make it packing fast, as good as piezo. And we also have the smart window made out of the wrinkle. So you will have a double-sided tape coated with a sunblock. So if you squeeze it, then it will become frosted by surface rocketing. And we also make a silencer. This silencer is just a box that absorbs the sound. Just like you put your empty water next to your ear to hear the resonance. So this is the tunable resonator. So another topic of my research is the soft robotics. We use a double-sided tape to make the weightlifting actuator. So this can do the make the bicep, can do the lifting. Of course, you can also make it looper that can lift up the either egg yolk or an apple. Okay. So in my lab, we also make a prepping drone. This is a bird-like drone. This is a tiny one. You can do a vertical takeoff, forward flight, flip backward, and even the soft landing from 3 stories.
Nice.
So here we also have the demonstration of the perching by using a simple hook. Okay. Yeah. After the introduction, let's come to the introduction of the course. So in this course, we are learning dynamics. Okay. In the short word, you are learning F equal to ma, Newton's second law. Okay. But here you have to distinguish what kind of motion. Your acceleration is dv dt, and that's the chain of velocity, and the velocity is the chain of the distance. Okay? So the force sum here is equal to the effect of motion. Okay? So this presents a different aspect from what you learned from the statics. Okay. So if the equation is so easy, isn't it? We're there. Okay. Yeah, but the complication comes from the actual motion. Your actual motion is not just a linear motion. Your motion, the distance could be a linear one. Okay. Could be a circular one. It could be anything. Okay. And the force wise also, force wise could be constant in direction, or could be any non-periodic or any arbitrary one. Okay. Okay. So that make the complication. Okay. So, but our objective here is to teach you to quantify this motion chain and the cost. And in the end, if possible, we also will introduce you the vibrations. So you need to learn how to formulate. Okay. One of the pitfalls in studying this subject is you may think this is a subject involving a lot of mathematics, but to be honest, so this subject involves more geometry than mathematics. Whichever you learned before, you have to change your mindset of studying. Please draw before you solve. Okay? So you need to draw what are the forces. You need to draw what is the geometry of the motion. Okay? So this is the subject of geometry. So when you are studying this part, we call this kinematic. Okay, what's the meaning of kinematics? Is geometry of motion. Okay. And what is kinetic? Okay, kinetic is the one that involves the forces. Okay, so the Newton law is kinetics when you're involving the forces. 所以我们上这门课大概分成两个部分，第一部分一定是上这个运动几何，基本上是要你从力、速度、加速度，找出它之间的关系。OK， 它可以是线性的，它可以是一个圆弧的。OK， 然后后面呢，上完这个运动几何，你就要知道这个运动的成因，所以你要知道你的力，这个力是可以是一个常数，一个固定方向或者变化方向，或者是时刻变化。OK， 但万法不离其中。Okay, so this is your Newton's second law. Okay, in the subsequent sections, okay, we will learn about this force method. Okay, we will learn about the impulse and momentum change. And we will learn about the work done and kinetic change. So here what you have is force method is F equal to ma, and impulse is F dt equal to the chain of velocity. And then how about the work done? Work done is the force integrations with respect to displacement is equal to the kinetic energy chain. Okay? So this is going to be the first half of the whole semester. Okay? So nothing more than that. Okay? 所以同学，你其实读这门课几乎你可以这个不记什么公式，如果需要的话，考试可以给你带一张 A4 size 的纸 ，OK， 那张纸那个公式可能对你这个比较方便，但是对于解答最重要的，你还是得要画出你的这个运动几何 ，OK， 没有正确的几何，没有正确的力 ，OK， 你的解答不是对应这个题目。Okay, so what you have to learn is about the geometry and free body force cycling. And for the textbook, we are still adopting the Hibbeler one. Okay, one of the pitfalls in using the Hibbeler one is, so they have a quite comprehensive presentation on the example and working out. You can read out the example, but don't read the text alone. You have to read the drawing. Okay, the ability to master this course is the ability to read the drawing and geometry. Okay, and also homework will have some questions coming out from textbook and some questions out some way. Okay, but when you do study, please don't just read the brief solution of the homework from the textbook, because the brief solution in the appendix of the textbook has no drawing. 所以你们在读这门课的时候，虽然作业你可以参考这个课本上的有一个简答，但第一大忌是什么？你就直接去抄简答。简答为什么不可以抄？简答它根本没有画任何几何图像 ，OK， 它只是公式 ，OK， 所以你即便答案对的，我只要题目转一个90度 ，OK， 那你的答案就错 ，OK， 所以出这道题不难的，就是考题不难，反正转一个90度，转一个45度，大概转180度，同学不会翻车了，转90度，同学就可能会翻车 ，OK， 所以你们自己看课本的时候，不要只是看它的简答 ，OK。Okay, for this part, okay, so different from last semester, we're going to introduce an in-class experiment. So from next week onward, you're going to be divided into 5-person or 6-person group. So you complete the experiment in class, okay, for every 2 weeks, okay. So what you have to do is bring out your handphone, install an app. Your handphone itself is an accelerometer and gyroscope. We're going to use your accelerometer, your handphone, to monitor the displacement. Let's say your arm, your leg, okay, your whichever experiment. We're all going to use your handphone, okay. So we're going to divide you into the 5 or 6-person group. So make sure you are in class, okay. Yeah, we will announce the experiment sessions. So after all the experiment, you got to do the reporting, okay, each group. So compile your experiment result, okay, and do tracking of the motion, do data analysis using your Excel, and then eventually you're going to complete the presentation. So to give you a flavor, okay, what we did before, okay, yeah, let me see. So I'll show you something that can be done with your handphone. So this is from other relevant class, and we bring it over to your current subject. Okay, take for example, so you might want to monitor the hand motion, okay? So you can use a stretch of a rubber band and monitor your hand angle. Okay, also you can do this kind of test, okay? So how much the forearm swing in the ball tossing. So you can use the video, okay, to track the forearm motions. Okay, at the same time, you can see that this student also wear your smartphone, okay, on the hand, on the forearm. So by doing so, then it is possible to monitor the hand motions, okay, visually, and also by this accelerometer. Okay, so in this way, so you have a real sense what is acceleration. 所以这门课其实也是回归到你第一章，所有的课，以往你可能都以前物理上过，但是你物理不做实验，你可能对那个感知不大好。然后一样的，你这个动力学，你什么速度、加速度，听起来都很玄的，好像都在纸上。然后，但是你现在每个人都手上有手机 ，OK， 那你就可以用你手机里面的加速度计、角速度计，然后去量测。所以我们会用你的量测方式去验证，哎，你这个理论对不对 ？OK， 那如果说理论是对的，那你量测出来，那应该要跟实验对应 ，OK。所以所有的这个有一句话就是说，所有的理论如果不能跟实验吻合 ，OK， 那都不对。所以实验是决定哪一个理论是对的一个唯一法则 ，OK。所以你们后面的话，你们就会做实验来验证一下你们所学的理论。Okay, so in this course, the teaching assistant will help out, okay, on the experiment, also the marking of your homework. So, okay, the timetable and venue is as here on Tuesday morning and on Thursday afternoon. Okay, so here's some info, okay, about me and about the teaching assistant. So you can approach them if there are any further questions. Okay, so far so good. 到这里还好吗？同学有提问吗 ？OK。 然后分组的话，我们比较简单。We're going to divide you into group according the sequence of the registration. Okay, so every 4, 5, every 5 or 6 persons, they will form a group. Then you're going to have your sessions next week. Okay, there are 2 sets of the notes given to you. Yeah, one set of the notes is from your textbook. So a comment on your textbook. Your textbook is really an exercise book. Okay, so many of you may not look closer into that, how we work in general. Okay, so we have learned about this kind of classifications. Okay, kinetics, kinematics. Okay, yeah. You know who prepared this PowerPoint? It's definitely not the author. What's wrong with the PowerPoint? What's wrong with the presentation? 所以这个 PPT 啊，是书商那边拿的，但是这个 PPT 是有问题，什么问题 ？OK， 这个问题是什么？我们在教动力学 ，OK， 我们不是在教你文字的，所以动力学最大的是什么？你的图要够大 ，OK。So in this case, most of the time, students don't even pay attention to the drawing. Okay, you pay attention to the equation. That's not right. You have to pay attention to the drawing. Okay. So this set of the notes, I still posted and let you read it. Okay, but I will use another set. Yeah. So this is good kind of for reading. Okay, but it's not really the gist how to master the coursework. Okay, so I will use some of the example inside the notes. Okay, but I won't go through the detail of the notes here. This from the textbook, the accompanying textbook. Instead, I will use this set. Okay, which I prepared myself and also with reference to the textbook by Miriam. Okay, so okay. So to start off, so we're going to start off learning the kinematics. What's the geometry of motion? Okay, it's a branch of dynamics that describes motions with reference to the forces. Okay, so you are talking about motion, then you have to describe about the positions and you have to describe the speed. So to start off, we're going to use an example that you are familiar. A spring, okay, a race on a straight racing path. Okay, who is the fastest? Okay, so let's take a look. Okay, for a rectilinear motion, which is a straight along this segment of the length. Okay, so for this racing path, so you can see that for section 2, it is a straight path for about 100 meters, but for the circular path you have how much is it? Yeah, another hundreds. Okay, add all together we have 400. Okay, racing path. So along this straight racing path, when you start the race or sprint, okay, you start from the same starting line, and then after after everyone start, okay, then you start counting the time and start recognizing who is the first to reach the ending point. Okay, 所以你在这个跑道上跑道有分大概两段，一个是直线的，一个是一个圆弧的。那直线跑道大概有100，直线跑道是100米还是50米？ ，OK，所以你在100米上跑，从起点到终点，OK，那都是一个直线运动，所以这个直线运动非常好叙述。So in the case of running along the straight path, so your distance should start from the starting point, point 0. Okay, and then this distance is the current position with reference to the starting point. Okay, so you can describe it using R. Okay, R can be distance, R can be radius. Okay, and then this R, this distance keep changing with time. Okay, so in this case, then you can describe the chain of the distance. 好，然后我们来看一下怎么叙述你的直线运动。So in the case of straight motions, you can describe the position P, okay, away from the starting point by distance S. Okay, if you move forward in the next second, okay, you may move delta S. Okay, so your point will change from P to P prime. Okay, so in this case, how do you visualize this chain of the equation? 我们先做一些名词解释。所以你在一个直线的跑道上，你的起点是 O，OK， 然后你的跑了一段时间到这个So you move from O to P. So this distance is S. So in the next second, you move to P prime. Okay, this becomes S prime. The distance traveled here is delta S. Okay. So what you see is the distance chain. Okay. But if you do clocking of your clock, okay, you got also time chain. Okay. So you can plot. Okay. The time and position. So your positions keep changing. Okay. Yeah. But in reality, you start from 0. Okay. So this is your O point, and this is your P point. This is your P prime point. Okay. Am I right to say? Okay. But this path is not straight. You don't have the position change in a straight line. You could possibly start low and then go high. Okay. Or you are going start high, going low. Okay, depends on how you do it. Okay, we're going to see it later. So let's have a look. Okay, in the case of race, the very important thing is how fast you start. Okay, so the acceleration is important. Okay, so now we have an unconventional race between a racing car and the cheetah. Okay, so why this comparison? Okay, so they are trying to match the acceleration of the cheetah. Okay, but you can clearly see they are having a different path. One is on the road, one is on the uneven terrain. So how fast it can run? Okay. Probably this is the in terms of the mile per hour, which is 70. So you might have to multiply the factors. Okay. Let's say 70 miles per hour. That's the speed there. 来，同学，这个70英里每小时转换成公里每小时是多少？问一下，哪一个同学
110。啊？110。
115 ，OK。G
2吧。
啊
110。
110。
2。
OK。好，我们看一下是吧？差不多112，没错。那请问一下，你机车有驾过这种速度？啊？机车驾这种速度会翻车，是吧？重心不稳。
要技术很好看。
所以你看刚才的那比赛，那个刚才跟花豹的比赛 ，So what's balance there? For a racing car, you have to prepare the road very flat one. Okay. On the other hand, for cheetah, they don't have the tar road. Okay. They can run on muddy road, grassy road. Okay. So this is the difference. Okay. And then next, to compare on the same basis. I think definitely cheetah, in comparison with the car, is different. Okay. Yeah. But let's next see the comparison with the fair conditions. 我们来看一下那个下一个那个比赛，这个是什么？这个是人跟那个鸵鸟在同样的赛道上，比较合理的这个比较。
No contest. The ostrich left Dennis in the dust without even trying.
Woo! That bird is fast! Well, I ended up going top gear because the ostrich started moving, trying to get away from him.
Dennis's top gear is nowhere near as fast as the ostrich's. Here's why. Speed is a product of downforce and stride length. With each step, the ostrich produces an explosive 1,900 pounds of force to propel it forward. That's more than twice as much as the 900 pounds a human can generate.
The ostrich's ability to produce force rapidly was remarkable. We're talking the fastest numbers we've ever seen and over 2 times faster than the best athletes we've seen.
The powerful downforce allows the ostrich to take a stride up to 16 feet long, nearly 3 times greater than Dennis's. This amazing power and massive stride is why these birds are in fact the fastest 2-legged creatures on the planet. What's more impressive is that even though Thelma breezed to victory going 26 miles per hour, her top speed is a blazing 45 miles an hour. Dennis gave it his all, but he's no match for the fastest creature on 2 feet.
When we raced side by side, I got him. But when I started chasing him, he was playing with me like your kid trying to catch you. You just like trying to play with them until they get close and you run away from them. Doctor was just totally just playing with me today.
Final scouting report: great speed in the 40, but she's got no hands.
好，看完这些，然后我们来看一下，你要怎么量测这个赛道上的这个距离。OK。好，所以刚才已经给大家介绍过这个什么叫距离，距离就是你这个位置的差别。P for position. So what is distance? Distance is travel as the chain of position. Okay. Okay, from position P, from position O to P, this is S. Okay, so sometimes there is a short form of writing. You can write this. What's the short form of writing? You can write S is equal to OP. Okay, so this is kind of a short form that you practice by reference to the drawing. And then next, so what is the velocity? As I tell you just now, imagine if you have the distance change over time. Okay? Okay, this is the distance change versus time. Okay? So this is distance, this is time. So the chain of this chain of the distance over time is defined as the velocity. Okay, in the limiting case, we have the ds, dt. Okay. So we sometimes also write a short form S dot. Okay, to represent the velocity, to represent the time derivative. Okay, so take for example, so let's say the fastest man take 9.69 seconds to complete the 100-meter race. Would you be able to calculate the average speed? Okay, when we talk about average speed, okay, you are talking about starting point, ending point. Okay, so how much time it takes? Okay, so this is average one. Is the one that take the final distance minus the starting distance divided by the final time minus the starting time. Okay, so in this case, distance traveled by this fastest man is 100 meters in the race, and it take 9.669 seconds. Okay, in that way, you manage to calculate the average speed. Okay, 所以上这门课不是看文字，你要把文字转变成图像。OK。所以你看到这样的一个叙述，你自己就要把它转变成图像 ，OK， 然后才来解，OK。And then next, so we also learned about the acceleration. So when you start running, you will have the faster speed change at the beginning, OK。哎，同学，刚才有没有看到那个汽车在起跑或者人在跑的时候，加速度是什么时候最高？起跑的时候还是跑到一半？起跑的时候为什么 ？OK， 起跑你如果说是身体前倾，那就更高啊，后面还有一个往后踢的这个板。Okay, in this case, when you start running, you're going to have the faster starting speed. Okay. So why is that the case? Okay, there is also another reason that you might neglect it. 哎，同学，我们看一下这个后面跑道，我们等一下会给大家看一下。好，起跑的时候，它的这个加速度最快，不仅仅是你往后踢的力最大，还有一个原因是什么？你猜得到吗？风阻啊？风阻。OK， 一个是风阻，对。那我们问一下后面同学，起跑的时候为什么比你跑到中间快？你可以说我累了，对啊，跑到中间累了。 那还有一个成因，可能大家都没想到。要不要猜一猜？起跑的加速度比跑到中场的时候快，为什么？看得到吗？
因为起跑的时候是两只脚一起发力的，
啊，
跑步，然后中间的时候是单脚走。
好，一个是力，对，还有一个更重要的原因，应该是顺带要讲的，就是说，你起跑的时候的加速是整个身体从零开始加 ，OK， 然后你跑到中间的时候，哎，有一个东西在帮你扯后腿是谁？谁在给你扯后腿？你跑到中间的时候，有人帮你扯后腿，你猜到吗？啊？你跑步的时候有人跟你扯后腿？你跑的时候，你的速度是一直在增加，但是你哪一根要着地的腿，那一根要出力的腿，它速度多少？零 ，OK， 所以你不断的是有一根腿，又减速了，所以实际上，你要怎么捕捉这个现象？你可能要修完这个动力学功的原理，你就知道你的极限速度。In this case, so that brings us to the previous slide. What is the terminal speed of running? Okay, the terminal speed of running is depend on your ground reaction force in the horizontal direction. It depends on your length of your stride, okay, and it depends on your leg mass, okay. Who is a good runner? Look at his leg. Then you can easily see who is a good runner because his terminal speed is going to be different, okay. If you look at the ostrich is high. Ostrich has the largest stride. Ostrich has the larger ground reaction force. And look at this leg. 所以你有没有发觉，这个鸵鸟脚怎么比人脚跑得快？鸵鸟脚对应的人的是哪一段？你们看到鸵鸟的脚？你的膝盖是往前凸还是往后？啊，往前嘛。那你觉得鸵鸟脚跟你的人脚差别在哪？OK， 看不出哈，来我们来放大。So let's take a look closer.我们看一下，鸵鸟在跑的时候是什么？鸵鸟的腿。So if you look at the anatomy of the ostrich leg. Okay, this is our foot. Okay, we have our toe, and then we have our ankle. The toe of the ostrich is what you see as the foot. Okay, and then the ankle of the ostrich is high lap. Okay, and then what is your calf? Your calf is also higher up. And what is your what is your thigh? Okay. 所以同学，有去吃烤鸡吗？炸鸡吗？所以你吃的炸鸡，小鸡腿是什么？ OK， 小鸡腿可能就是这个你的小腿，大鸡腿，大鸡腿，这个是就是上面的那一块。所以鸵鸟在跑的时候，你看不到它的这个大鸡腿。OK， 你看到只有它的这个小鸡腿。OK， 然后为什么要吃？有吃凤爪的吗？凤爪是吃哪里？凤爪什么？鸡脚有肉吗？没有肉。那鸡脚吃什么？皮？没有，不吃皮。鸡脚吃什么？来，女生，鸡脚吃什么？来，女生要养颜的。鸡脚吃什么？鸡脚又吃皮？不是吧？那鸡腿、鸡胸皮很多。来，有没有正解？来，或者男生有研究的，鸡脚吃什么？啊？胶质。啊，这个胶质是什么？胶原蛋白。啊，这个肌腱、韧带 ，OK。所以你看到没有？哎，为什么那个鸡啊，这个鸵鸟啊，跑都是用腿在跑，跟脚板在跑。它这一块也是算脚板，然后这块才是鸡。所以鸟跟鸡怎么跑的？你可以比较形象的，鸟跟鸡在跑的时候，就像跳芭蕾舞一样，是垫着脚尖在跑。OK， so why does the chicken or ostrich have to tiptoe for running? Okay, because you can minimizing the weight. There is no muscle. Okay, there are only tendon. Okay, tendon in your foot. Okay, very little muscle. So in that way, if you refer back to my formula, okay. If you refer back to my formula, FL over M lag, okay, and then take the square root. This is the terminal speed. The way the ostrich can run fast and man is relying on greater force, greater stride, and lower leg mass. Okay, so that's because of they are only tendon. They are tiptoeing during the running. Okay, so of course, 来我们问一下，来下一个问题，猎豹为什么比狮子跑得快？啊，不要亲，亲在哪里？啊？骨头啊，直接点，亲在头。OK， 所以来再问一下，猎豹头亲了，那牺牲的是什么？来 ，So what does cheetah sacrifice for weight reduction and even the head weight reduction? 来，有笑笑的同学，我知道答案，对你啊，你觉得牺牲什么？骨头轻啊，它头就小了嘛，头小了是吧？头小的话，那个下巴也小了，下巴也小了，结果什么？牙齿也小，那牙齿也小，那个咬合力就小啊，所以猎豹抓猎物基本上是给猎物放血，它杀不死猎物，但是这个它狮子当然咬合力大，但狮子的这个重力太大，所以狮子一般这个大头没有出去抓猎。So in this case, so we define something. Okay. So let me quickly wrap up before I end. Okay. So the acceleration. Okay. So in this case, so we take example of the racing car. How fast a Tesla can accelerate? Take for example a racing car. Okay, not okay. not necessarily racing car. A Tesla can accelerate from 0 speed to 60 miles per hour in 2.5 seconds. So this is matched with what the racing car achieved. Okay, how much is the acceleration? Can you go and calculate? Okay, so in this case, so it's quite a straightforward calculation, but from the drawing, you got to change it. Okay, let's see. Okay, just now we draw about the distance, time plot. So you could possibly have this kind of curve. So you can see this. This is the gradient, velocity 1. This is the gradient, velocity 2. And this is the gradient, velocity 3. Okay? According to the drawing, ST plot, then you're going to plot the velocity versus time plot. As you can see, the starting value, the starting speed is 0, no doubt. And then the next speed is your V1. And then your next speed is your V2. And then your next speed is your V3. Okay, if you now connect up the drawing, okay, then you have the velocity versus time curve. Okay, and then next, you can do one more derivative. Just now we tell you velocity is ds dt. Okay, and then next you can do acceleration is equal to dv dt. Okay, and this is the slope. Okay, if this slope is constant, okay, the acceleration versus time is going to be a constant part. If it's accelerating, so it's going up. If it is, going down to the negative area, then it starts decelerating. Okay. So as for the running, so we come quickly. As for running, you can trace the running by seeing the blur image. You can trace the running by laser. You can trace the running by your headphone. Okay? So what you see just now is when you're running, okay, if you capture the image and do the tracking, you can see the position change. That position change is the red line. Okay, it's not the straight curve. But if you want to find the average speed, then you just connect the final position to the starting position divided by time taken. Okay, how you obtain this? This is obtained by taking the video by camera for every 30 meter. So you complete the nearly 100 meter range. Okay, so you see that when video is doing the tracking, video will see the position. Video will see also the change of the speed. Okay, so what you're going to have by video taking is the range and the velocity. So at different positions, you're going to have different velocity. Then this is different from at different time versus the velocity. So in the next lecture, we're going to study how do you correlate the velocity distance relationship to the velocity time relationship. Okay, with this now, then we have our lecture wrap up. So this distance, this acceleration can be taken as velocity change with time, and it change with the distance too. Okay, in the next lecture I'm going to cover this in 2 more detail.